So we will continue with the discussion analysis of static cable. So we are doing the mooring analysis. Now these are the two basic equations we have derived last class, that is your dt prime, this is equals to w sin phi ds, and the other one that we have derived was t prime d phi is equals to w cos phi ds. Now if you divide those two, you will get dt prime by t prime. You write in this form, sin phi over cos phi. So this we have already derived. Now in this equation, this you integrate. Now sin phi d phi you can write as this. I think you can write this as d cos phi. I just put a negative sign. So this expressions becomes minus d cos phi over cos phi. So now you can integrate this. So this will be your expression if you integrate. This will be log of t prime. This will be minus log cos phi. Now you have to find out the constant c plus c. So this is your expression if you integrate this expression. I think this was equation number 7, this was 8 probably, you just check, and this was 9. Now starting from our this chain cable, the diagram that we had drawn, now there are 2 points which are your boundary conditions. So boundary conditions will be at the seabed and at the waterline. So this is your chain cable. It is assuming it is a shape of a catenary, and at this juncture it becomes horizontal with the seabed. So now it is anchored at this point. So this is your T prime. There is a tension in the cable, and out here at the water surface this becomes, this is TW or T prime W. This at the water plane it will become that. Now here at the this juncture where it meets the seabed, so if you draw a tangent, and the tension will be T prime subscript 0, and this angle will be phi equal to phi 0. So these we have to substitute these boundary conditions in our problem in order to get the expression. Now here at this point, this will be T prime will be equal to T prime 0. Okay. So now let us find out. So there are the two objectives we have to find out in our previous diagram, that the x value. This is what we are aiming at. First you find out the length of the chain cable, then this distance along the x axis and along the z axis. So we have to find out the length of this chain cable, and this horizontal, this distance is x. And you have to find out the length of the chain cable. From here, the total length, you subtract the portion that is lying on the seabed. So this will be S0. So the total length is S minus S0. You have to calculate this, find out x, h of course you know, and calculate the tension T. So this is the crux of the problem what you have to solve. Now the equations that you get out here, so you give boundary conditions and boundary conditions are the one that I have just stated, and here you substitute. So how much, what is your equation? So the equation that we have got is log t prime. So you say this is at A, and this is let us suppose this is at point B. So at A you substitute boundary conditions. So boundary conditions are phi equal to phi naught, and the other one is t prime is equals to t prime naught. So then what happens to this equation? So log of, what you will get? So log t prime naught. So we have to calculate the value of c. So this is minus log cos of phi naught. So now you can get your c value from this t, if you know t naught and phi naught. So but how to know these values? So this is see t naught, actually it is lying at this point, that is the horizontal force at anchor and the inclination at this point. So those I think you have to find out from instruments, otherwise you cannot know that. Now here, so from here you the value of c, what is the value of c? So this is log of so if you want to analyze this chain cable, see we have to find out t prime naught and phi naught. Now what is normally done in this, you have to have certain instrument, so you have to do some line instrumentation. You calculate the horizontal force at anchor at this point, and t prime you can put some this thing, what is called strain gauge out here. You can calculate the tension at other various points. So normally in varying things, you know, in structural analysis they do this kind of instrumentation. So similar thing you will find that they do in find out the stresses in piles. So I think probably in your offshore technology you will talk about the seabed piling. There also you have to instrument. So here you so now we are getting C from this. So this you can simplify. Then what is your expression? So this will be log of t prime naught multiplied by cos phi naught A into B. So now you are getting the expression. So your expression is coming like this, log of t prime. So this is equals to minus log cos phi. And what is the value of C? So C will be log of t prime naught cos phi naught. So now again you can simplify. So this will be log of t prime naught cos phi naught over cos phi. So now we have simplified this. So from this equation you can calculate your, since both sides are log, so this t prime, that is your tension, becomes equals to, this is t prime naught cos of phi naught over cos phi. So this is your expression for tension at any point on the chain cable. Now this prime indicates what? Remember the first equation that we have done, what was the significance of the prime? Prime actually we have corrected for hydrostatic pressure. So if you look at this equation, so what I have written, so what was the correction? This expression. So this expression was your T prime. So that means that is just the correction for your hydrostatic pressure. Anyway, I think I have written here. So this is your correction for T prime is the tension in the chain cable corrected for hydrostatic pressure. So this is our expression, and remember we are taking the weight of the chain cable, that is taking into account your buoyancy, the buoyancy term. So that is the net weight which is acting downwards. So now the other terms that are coming is, we have the first equation that we started out. The two most important ones are these two expressions you should remember. The other equations will follow from this. Now from 8 you write, now we have to calculate the length of the chain cable. So you use this equation. So from 8 you write the serial numbers, you just check because you put down the correct serial number. Now what you can find out from this is the length of the chain cable, ds. So this is your equation 8. So from here we can calculate the, first you find out the expression for ds. So ds is T prime d phi divided by W cos phi. Now you integrate this expression. You put the boundary conditions and integrate. Now T prime, what is the expression for T prime? So T prime, you substitute this expression. So ds will become, so maths here, the maths is not that difficult, so you can easily follow. The only thing that we have certain spells of integration, that's all. So differential equations are not come. So this is a very simple analysis. So this will be your d phi over W cos phi. So now your ds is coming as cos squared phi. So if you want to find out s, you just integrate this, the right hand side. Yeah, W cos phi. So one W term will be there. Now it's okay. So now you integrate this expression. So we are interested in calculating the length of the chain cable, but for which portion? Portion that is of the catenary portion. So you put the limits of integration as S and S naught. So this will be, you just integrate this. So what are your variables? So you bring this, the T prime naught, that is your initial condition at phi naught. So this is, you are supposed to know this from instrumentation or from physical examination of the chain cable by divers going down. So this, you put this divided by W, and this expression you integrate between phi naught and phi. So that is d phi over cos square phi. Now if you integrate, you check your integration terms. So this will be, what is the expression for integration of cos square phi? So this will be S minus S naught, and on the right hand side you will get tan phi. So those of you just check on any book on integration and differentiation, you will get this. So this will be from phi naught. So ultimately your equation is coming like this: S minus S naught, this is equals to this will be cos phi naught over W, and this expression will be tan phi minus tan of phi naught. So we are getting this expression. So this is the catenary part. You write in brackets catenary length. Now please don't talk. This is your catenary length. Now you find out the horizontal component of x. Say this is your expression for your x, the horizontal total, and again your x naught you subtract from the anchor length. So this is your x naught. So you find out this distance. So this distance is x minus x naught. So what is the expression? Say you take a element of length along this line, say call it dx, followed, and this length is say ds. Now can you get the expression? The angle is, you write phi, is a phi angle. So from this you can calculate dx. So that is dx is ds cos phi. So good. So the expression is dx over ds. So that is equal to simple cos phi. So from this dx is equals to ds cos phi. So now you substitute the expression for ds. So what was the expression for ds that we had got? So ds was this expression. So you write cos phi, you bring it forward, so multiplied by ds. So ds is t prime naught cos phi naught w cos square phi. So this again you multiply it by d phi. Now you simplify this, how much you get? And then you integrate. So this becomes t prime naught over w. So this is the constant term. The other term that you will get is, the variable term is d phi over cos phi. So now you integrate. If you integrate, you will get the expression for x. So we can write in this form. So that is x naught x dx. So this will be t prime over w cos phi naught, and you integrate this expression d phi over cos phi. So this is your phi naught to phi. So you integrate this, you get x minus x naught. But what is the integral of this 1 by cos phi? So x minus x naught is equals to integration of 1 by cos phi, how much? You check your again your you will get this expression. So this is a little bit large. So this x minus x naught is now similarly you find out, you calculate z minus z naught. You calculate z minus z naught. If you want to calculate z minus z naught, then what is the expression that you should use? Ecolan, stop talking. You find out z minus z naught. I have shown you how to calculate x minus x naught. And after that you calculate the tension T. So what is the value of dz over ds? Now similarly we have started you with this expression, that is dx by ds. So it is just simple cos. So this will be cos or sine. So this will be sine phi. So now from this expression you can calculate z minus z naught, that is the vertical projection of the cable line. So you have calculated the horizontal projection, that is x minus x naught. So this is called the horizontal projection of the catenary. Sorry, this is horizontal projection. So this expression is simple. You take dz over ds is equal to sine phi. So from this expression, if you integrate, but you have to substitute the value of this ds. So in our previous expression, what we have substituted? ds was this is sin phi multiplied by what was the, you find out what is the expression for ds. Now remember, in the expression for ds we had substituted t prime, isn't it? So ultimately with t prime naught, that is at the seabed, we are getting this. Now you do this, do the integration. This is the expression for ds. Is it right? So now you, what is coming? So you take out your constant terms outside. So this is coming as divided by, this is cos phi naught. And the other term that you will get is sin phi. So we are getting sin phi out here. So this will be cos square phi. Cos square phi multiplied by cos phi is coming, again d phi. So if you integrate this, you will get z minus z naught. So that is your vertical projection of the catenary. So but here if you integrate z minus z naught, integration will be dz z z naught. Now what is the, after integration, what you will get for this? So this will be phi naught, limits will be phi naught phi. Now you integrate this expression. So integration is, if you remember, you put simply put sin phi d phi equal to this expression. Put r equal to cos phi. Then you will get, what is your d of cos phi? This is minus sin phi d phi. So this expression you can write, but you change your limits, phi and phi naught. So this expression will be integral of how much? Say minus d of cos phi. And this will be cos square phi. So now it is simple. So this will be how much? So now can you do it? So if you do this, this will be 1 by r. So our expression is coming as z minus z naught. So this will be how much? Okay. So this is the expression for z minus z naught. So what else we have found out? How many items? We have found out the length of the chain cable s minus s naught. Then we have found out x minus x naught. Your x minus x naught is not there, no? Yeah, x minus x naught we have found out. So the most complicated expression is the horizontal length on the seabed, isn't it? This one, because you are having this log term. And the other is the z minus z naught. Now you calculate your tension. Now phi naught is the angle made at seabed. You write during contact. Now, if you want to simplify this equation, you can write phi naught equal to 0. Now, what was your expression for the tension corrected for your hydrostatic pressure? Cable line tension, what was the equation we had got? Remember that first expression we started out with? So I have given you the expression for dt prime, isn't it? Then from that we have derived the expression for t prime. So what was our expression for t prime? So t prime we have got as this expression. This is t prime naught cos phi naught over cos phi. So this expression was coming from the two equations, the dt and t prime equations, which we have divided and we have found out. So now can you find out from this expression? You substitute this phi naught equal to 0. Since we are simplifying this, you put, so cos phi naught is going to be 1. So your expression for t prime is coming as t prime naught over 1 by cos phi. So this and this expression you remember. Now next you calculate horizontal component. Horizontal component of tension at waterline. So what was the horizontal component at seabed? So horizontal component of cable tension you write at waterline. So that is your winch. Winch tension was coming how much? Winch tension we have written this as T prime W. Now how much is the angle? So angle was given as phi W. So here you will find this is TH. So we will come across a simple tension. It will come from free body mechanics. So how much is the horizontal tension cable? It's quite simple. You just take the component. So at waterline, the winch tension is TW. So how much is TH? TH obviously will be TW multiplied by cos phi W. But you have to know both TW and phi W. Now this TW and phi W you have to know. TW is actually you can straight away find out from anchor winch. But phi W how you are going to find out? So phi W also you have to find out from ship deck. So this is fine. Now what was our expression for T prime? So we will come back to this equation, that is your TH later on, but you tell me the expression for T prime. So T prime was the corrected tension minus what? The hydrostatic pressure. So rho G Z A. A is your cross section area of chain cable. Now here what is the expression for T prime naught? You tell me this T prime naught at water plane. What was the expression for T prime naught? So T prime naught is T prime multiplied by cos phi. Now at water plane what is going to happen? This expression at water plane if you write, so this T prime naught will be equals to T prime, you just simply put subscript W. So this will be cos phi W. So this is your at water plane or at water surface. You simply put T prime W out here and cos phi W, that is all. Now you compare. Now at water surface, this expression, that is T prime naught. Now you just see that you have put a prime out here, that means you have corrected for hydrostatic pressure. So this will be T W minus how much? You write the expression and then you put Z equal to 0. So this expression is all right. This is cos phi W. So I have simply written the expression for T prime naught. Now at water surface, what is the value of Z? Z at water surface is 0. So then your expression for T prime naught becomes what? So this is simply T W cos phi W. Now you compare the expression that we have obtained earlier. So what we are getting now? So previously we have obtained TH is equals to TW cos phi. So this you put some number out here, say this is 9 or 10, whatever we are forgetting. So compare with 9. This is 10, no? So this, you write this as 10. So compare with 10, how much we are getting? So you write this as 11. Comparing with 10, we get TH equal to T prime naught. So that means, what is our inference? That is, we are balancing the horizontal forces. Do you follow? So that means in your free body diagram, so if your TH is in this direction, you are simply getting T naught in the opposite direction. The horizontal forces has to be balanced. Now what about the vertical forces? Vertical forces, the TW sin phi, you have to balance the weight. Now what is the condition at seabed? Now you choose the conditions at seabed. The mathematics is not that difficult, but you have to work out. So x0, you put this, you start from x0 equal to 0. What is the value of z0? Seabed, mind you. Seabed is minus h or plus h? Minus h. And you set S naught. This you start at 0. In order to simplify the problem, we are making all these assumptions. Phi naught will be equal to for chain lying horizontal on the seabed, say phi naught equal to 0. Now you write down the expression for S minus S naught. See, what are the three equations that we have just now derived? The three equations x minus x naught and your this S minus S naught and Z minus Z naught. Now your x minus x naught that we have derived is quite a long expression. So x minus x naught, this is equals to t prime naught over w. Now these are fundamental equations which we have to use now. So this multiplied by log of, this is a little bit long expression. So this is sec phi plus tan phi. You put some number on this, otherwise every time we have to write this down. So this is sec phi naught plus tan phi naught. Now you tell me the expression, the other expression is Z minus Z naught. So this is one relationship which you should not forget. So let us write this as 12. Or the other expression that we have derived is Z minus Z naught. So what was our expression for Z minus Z naught? That is the vertical this thing. So multiplied by 1 minus cos phi naught. Now you tell me S minus S naught. So that is the expression we require now. So this is, say, equation number 13. So S minus S naught, how much we have derived? This expression we have just derived now. Actually, these papers are actually loose. What was our expression? This. So t prime over multiplied by cos phi naught over w. Now you on all these expressions you substitute these boundary conditions, seabed conditions, and see how much you get. So these are the three important equations, 12, 13 and 14. So these three equations actually give you the parameters of the chain cable, that is the length of the chain cable and their projections on the horizontal and vertical axis. Now you simplify with this seabed conditions. So seabed conditions, if you in this expression for S minus S naught cos phi naught is how much? So this will be cos phi naught. Sorry. Yes, over here. And remember, you are starting with S naught equal to 0. So you simplify 14. So put boundary conditions in 14. Or rather you write put seabed conditions. So this will be simply S. Your S naught is 0. And then on the right hand side we get, instead of cos phi naught you will get 1. So this will become T prime naught over W. And tan phi naught will be how much? Your phi naught is, we have assumed phi naught to be 0. So this expression simplifies to only this expression, tan phi. Now we have found out T prime naught is equals to, what was our expression for T prime naught? That is, we have derived that is equal to TH. Somewhere I have written this, no? So you substitute that. So this equation, let us write this as, see how much the sequence I am not following actually, say from 15. So S becomes equals to TH over W multiplied by tan phi. So now we have obtained a very simple equation for S. You are able to see that? Is all simple seabed conditions and mathematical jugglery, that's all. Now you derive this for x minus x naught. What was the expression for x minus x naught? And you substitute the seabed conditions, that's all. So x, so this we are, you just tell me what is the equation, what should I put equation number? 15 I have already put inside, so let us put this as 16. 15, and then you don't put any number out here. So your expression for x minus x naught was T prime naught over W. Now you simplify that, you put boundary conditions, you will get the answer. So this will be log of Now remember, this is only static analysis. We have not started dynamic analysis. And the other one was quasi-static, isn't it? So here you substitute, how much this becomes? T prime naught is TH, isn't it? So you just write TH. TH over W, your cos phi naught becomes 1. And here this will be log of, the other term will be how much? So this will be simply log of 1 by cos phi plus tan phi. So this is equation number, how much I will put? 16. What? Now you tell me what is the expression for, so this is your x. X naught we have started as 0. So your x is equals to this. Now you find out z. But you substitute in this expression, when you substitute, you don't put z naught equal to 0. Because your seabed condition, what is your seabed conditions? Seabed condition, you put z, we have said z naught equals to minus h. Don't put z naught equal to 0 in the other equation. So this you complete at your home, so we will complete this and then we will find out the expression for z plus h. There's still a long way to go.